A circular disc with a groove along its diameter is placed horizontally. A 1 kg block is placed as shown. The coefficient of the friction is 2 by 5. The disc has an acceleration of 25 meter per second square in the left hand side direction. Find the acceleration of the block. Now basically if I draw this in 3D, the disc will look somewhat like this. There is a block which is in this direction, okay, which is placed inside the groove. So on this block there will always be a normal force which acts in the vertically upward direction, and there will be a mg which acts in the downward direction. So normal force will be balanced by mg over here, so N will be equal to mg. So due to this normal force there will be a friction force. Now over here, if the disc is pulled in the right hand side direction, the block will have a displacement, or the resultant acceleration is somewhat in this direction with respect to the block, with respect to the disc. So now over here, basically if the block slides down along this direction, it is a constrained motion. So now for this disc, the frictional force due to the normal force, it will act in the backward direction. So this frictional force F1 will be equal to mu mg, okay, which acts in the opposite direction. Now if the block slides in this direction, there will be a pseudo force which acts in this direction, which will be equal to A naught. If I draw it over here, there will be a pseudo force which acts in this direction, which will be equal to A naught, okay. Its component in this direction will be equal to, now this is equal to theta, so by alternate angle this angle will also be equal to theta, so it will be equal to A naught sin theta, and in this direction, along the direction of the groove, it will be equal to A naught cos theta, okay. So along this direction it will be equal to A naught cos theta, along this direction it will be equal to A naught cos theta, okay. There will be a friction force which acts in the opposite direction over here, which is equal to, due to the A naught sin theta in the opposite direction, is equal to mu A naught sin theta. So now the resultant force, if I see the resultant force due to the acceleration, there will be a friction force which acts in the backward direction. Let the friction force be equal to F2. So there is F2 which is acting in the opposite direction. So the resultant force is over here A naught cos theta in this direction and F1 and F2 in the backward direction. So A naught cos theta minus F1, or I will first write it down as F1 minus F2 will be equal to MA, okay. So A naught cos theta, over here the cos theta will be equal to, the cos theta is given as 4 by 5. So A naught, I do not know the value, okay, will be, or it will be equal to MA naught. Since I am writing the force, it will be MA naught cos theta, which will be equal to MA naught cos theta will be equal to, mass is given as 1, A naught cos theta, which is equal to 25, into cos theta over here is equal to 4 by 5, minus the frictional force F1. The frictional force F1 is equal to mu mg, which is equal to 2 by 5, m over here is equal to 1, into g over here is equal to 10, minus F2. F2 over here will be equal to, the frictional force over here is equal to, mu A naught sin theta, or if I consider this is the acceleration, if I write down the force, it will be equal to mu, that is 2 by 5, A naught is equal to 25, sin theta over here is equal to, cos theta is 4 by 5, so sin theta will be equal to 3 by 5, will be equal to m into A, which implies A will be equal to m into A, m is equal to 1, 1 into A will be equal to 1, A will be equal to 25 into 4 by 5, which is equal to 20, minus 2 by 5 into 10, which will be equal to 4, minus over here 5 into 2, which is 10, 10 divided by 2 is 10 divided by 5 is 2, 2 into 3 is equal to 6, so which is equal to 6, which will come out to be 10 meter per second square. So the acceleration of the block with respect to the disc will be equal to 10 meter per second square, okay. The acceleration of the block is equal to 10 meter per second square.